Okay, hi everyone. This will be a probably 5 minute screencast, no more. This is from the take home, the question number 4. At the end of the day, you're supposed to get a really beautiful expression for sine of theta over 2. Okay, and it's lovely. And if you want to see the algebra kind of wormhole mess that you make to get here, it's just algebra, and let me see if I can rattle the names off. You can look at Jason's work, you can look at Maya's work, you can look at Daniel's work, you can look at Fino's work, though Fino's was unsimplified. There are a bunch of people who went the way of algebra, but what I will say that I'm surprised that none of you, other than Nancy, were savvy and cunning, and I know you are all savvy and cunning when you need to be. You did not need to go into the algebra wormhole. So let me show you what I'm surprised that none of you kind of thought to yourself to do. Okay, you know that the radius of this circle here is r. The radius here of this circle is s. Okay, and a lot of you got the fact that, because these circles are tangent to that line, therefore these angles here must be right. Okay. And then you were asked to find an expression for sine of half of theta, and half of theta is right there. It's a little small, so I can't get into there, okay? Because the entire theta here, the entire angle rather, is theta, right? Okay, so this is what none of you saw, but again, if you want to see the algebra of how to get to the beautiful outcome that I'm going to show you, you can just look at Daniel, Maya, Jason, Fino, I think Mateo. If I left you out, I'm sorry, but they got there by way of just algebra, just the long, hard, kind of cardiovascular way. But you could have also done this. And Nancy, kudos to you for seeing that there was a shortcut. All right, here's what you do. Ready? You could have just gone over here and said, I'm going to do this. Draw horizontal over this way. Okay. And if I draw horizontal, do you see something? This triangle right here. Okay, and because of the property of parallel lines, this line is parallel to this line. Guess what angle this here has to be? These two angles here are corresponding angles from way back in your dusty brains of geometry. That's theta over 2. And sine of theta over 2, if you look at this yellow triangle, is going to be opposite length, right, over hypotenuse. Oh no, what are these lengths? Well, let's see. This length right here, if this whole length is s, and this length is r, but this length r, look, this length has to be this length. That means the blue length here is s minus r, right? So that's the opposite. What's this hypotenuse length? Well, that length is the same as this length. And this length is r plus s. So the hypotenuse here is s plus r. So at the end of the day, when you are asked to find the sine of this angle, it is opposite over hypotenuse, or just merely s minus r over s plus r. No algebra wormhole required, but if you want to see the algebra wormhole in all its glory, consult Maya, Mateo, Daniel, Jason, Fino. Gosh, I know there are more of you, I just forgot. Okay, bye.